Hello everyone, welcome to Universal Light. Please like, share, comment, and subscribe. In the last class, we were studying computer science for O level and IGCSE, and the book that we are using as a reference is from Motor Education, which has been referred to us by Cambridge for IGCSE and O level appearing students. In the last class, that was part 1, we studied the inputs, logic gates, and an example related to it, for which we also solved a truth table. Today we will be solving some further questions and we'll be moving further ahead in part 2, and we'll see some other difficult questions which have some tricky parts to it that students find difficult to solve. Here we have our first question. If you look at the question, it says that show why. I told you in the last class that show why means that we have to draw the logic circuit here. Okay, now let's begin. The statement says y is equals to a or b and not a and b. Now the difference here that we will find is that not is being applied to a and b both. Let's begin. We have only two inputs, a and b. We'll first solve this bracket which says a or b. A or b means a plus b, which means we will be drawing the logic gate for a and b. Okay, here we are done with the first bracket, that is a or b is done. The next bracket, now as we all know, this and is the final output, that is why we are not going to look at it until we have drawn the entire circuit. Now it says not. If you see here, this not, a and b are in a bracket and this not is being applied to the entire bracket here, isn't it? It means that both the inputs, both the values that are given inside the bracket need to be multiplied with not. Multiplied with not means that not a and not b. Okay, so if we expand the bracket, it means not a and not b. Let's draw it. You will take a junction from a and you will bring it downwards. Then not b, you will take a junction from b and you will bring it downwards. Here we'll be drawing the NOT gates for it. Okay, and a NOT gate for B, sorry, A. Now through the AND gate we will join both of them. Now we will come to the final gate, which is the AND gate. Okay, now we will be drawing the AND gate because we are done with this bracket and we are done with this bracket. The only thing that is left is the AND gate. Let's draw it. We will combine this gate and we will be combining this gate. Okay, and then through the AND gate we will join them, and this gives us why is this way. Okay, you always have to make this thing in such a circuit where it says show y. Moving on, the next question says produce the truth table and logic expression for the following. In a question which says produce the truth table, it means that you have to make the truth table. Okay, look at the requirement of the question. It says truth table and logic expression. However, the logic gate has been given to us. Let's start off by labeling the gates first. This is AND gate. This is OR gate. Which gate is it? It is NOT gate. And this here again is OR gate. Okay. Now how do we do that? Firstly, look at the number of inputs and the names you have for them. A and B. Okay. You have two inputs, A and B. Let's draw for them. Firstly, make A. Now A and B are joining together. Look at the very first gate. Let's do this first gate, second, third and fourth gate. Now this is AND gate, the first gate. AND gate is being made by A and B. So A and B. Okay. The first gate is done. When it's just the beginning of you learning the logic expressions, it's the best way. Even if you are attempting in the question paper, it's good that when you have made the logic expression for one of the gates, you put a tick on that. It will make sure that you have covered all the logic gates. Okay, so the first gate is done, put that in brackets. The next gate we have is the OR gate, and if we see further from the OR gate, we're having the NOT gate, which means that this NOT gate is being applied to both A and B. So if you want, you can do this way. NOT taken in common because it's applying to both of them, A or B, or it can be done in another way. It is NOT A or NOT B. So it's just a shorter way of writing this whole expression. However, it's completely up to you the way you like. Okay, so this and this means the same. This and this, both of them mean the same. Now the last gate, that is the OR gate, which is the final output, is to be put in between the brackets. Okay, now from this logic circuit we have to make the truth table. Okay, now the logic expression is given to us and the logic gate is given to us. Now the only thing we are left with is the truth table. Now it's completely up to you. For instance, in a question it is not given to make the logic to produce the logic expression. If you want, you can do it for ease of making the truth table. However, you can directly also make it from the circuit. So as we are making the truth table, I'll make sure that I go side by side by explaining both how we are making the truth table from the expression and from the gate. Firstly, we all know we always have to write the inputs, that is A and B. Okay, the inputs for A are 0011. These are constant, they do not change. The CIEs, that is your examination when you will receive, it will always have this already given to you. This is constant value. This is not something that we are making by ourselves. This is the constant value that will be given to you. Okay, now they are saying that the first thing they are saying, A and B means multiply. And if you look at here, the first gate we are making is the AND gate. It means we will multiply it first. A dot B. 0 multiplied by 0 will give you 0. 0 multiplied by 1 will give you 0. 1 multiplied by 0 will give you 0. And 1 multiplied by 1 will give you 2. However, here we write 1 only. Clear? Now the first gate is done. Then they say not A or B. It means you have to, what does this gate imply? This gate implies both the values of A and B are being inversed, right? NOT gate means the function of NOT gate is to inverse. So A A inverse, B inverse. The inverse of A is double 1, double 0, and for B is 1, 0, 1 and 0. Okay, the value 0 is turned to 1, 0 is turned to 1, 1 is turned to 0, 1 is turned to 0. Similarly is what has happened with gate B. Now both of them, the inverse of A and B are being added because it says OR gate, right? Both the inverse are being added together. Here you can also say this is the not NOR gate because you just simply add A and B and inverse the output you get, or you do it this way, you will get the same answer. Let's add them. Inverse A, inverse B, add them. Oh sorry, I have written the multiplication sign. It is to be added here. 1, 1, 1 and 0. Label this as P and this as Q because we are adding these two brackets. Instead of writing the whole thing, we label this as P or Q or any other name that you want. Okay, so I did a small mistake during the explanation. I said that it's up to you if you want to add the values of A and B and then inverse them, or you want to do it the way that I've did here. So I'm really sorry about that, the explanation I've given, because you will be getting the wrong answer that way. For example, let's see, A plus B, 0, 1, 1 and 1. If we inverse that, as I said in my explanation, it will give us 1, 0, 0 and 0, and this is completely different to what we have stated here, isn't it? So I am extremely sorry for the miscommunication or the misunderstanding that I made here. So please make sure not to do this mistake. Okay, now the final gate, that is the OR gate, will be added up. P plus Q. Let's highlight them. The values of P are these and the values of Q are these, and we'll be adding them. 0 plus 1 will give you 1. 0 plus 1, 1, 1 and 1. Which is your final output for this? So the value of X is 1, 1, 1 and 1. 1, 1, 1 and 1. Okay, clear? I hope no misunderstand, like all the misunderstanding that I created was clear right now, is clear right now. And yet if you do have any confusion left, even though I've explained, after my level best to explain it to you, even if then if any confusion is left, you can always ask in the comment section. Now we'll move ahead and see some other types of questions and some other things that you will be addressing when practicing Boolean logic. Okay, the next thing that we are learning here is how to make logic expression from truth table. Okay, so one of the truth table that we have here is, okay, so this is the truth table that we have. Now when we have to make a logic expression from the truth table, first thing that you need to highlight is the outputs. Okay, firstly what you will do is you'll highlight any output which has the value 1, and you have to highlight the entire horizontal column. For example, here we have 1, we're going to highlight this entire thing. Here we have 1, we'll highlight the entire thing. Okay, now always remember the values that 1 and 0 have. Okay, 0 has the value not. the gate 0. 0 represents the gate not, and 1 represents the gate and. Now let's form the logic expression. What you have to do here, okay, now two logic gates are joined together with the help of OR gate. Two logic gates are let's see how we are going to be forming the logic expression. Firstly, 0 means not. It means not A. 1 means B. 1 means and, sorry. And B. Done. The next gate says A. 1 means and. So and B, because none of them is representing OR. Oh, sorry, not gate. And we are now going to be joining these gates together with the help of OR gate. Okay. This is how you simply have to make the logic expression from the truth table. I'll be giving you some of the questions that you'll be solving for yourself, and in the next video that we'll be beginning with, I'll always be discussing the answers for any homework that I'll be giving to you. This is for your practice. Okay, let's view some of the questions that you'll be solving yourself. Okay, so this is your homework, and what do you have to do here? You have to make the logic expression from the following truth table, and we'll be discussing the answer for this particular question in our next class. Let's just review what we have studied today. Today we solved this, we made the logic circuit from the following logic expression. We produced the truth table and the logic expression from the following circuit. This is the circuit that we used. Okay, this is the logic expression that we made, and this is the truth table that we made. These are the input values and this is the output. Okay, then we practiced how to make the logic expression from the truth table, and at the end I have given you a homework, that is to make the logic expression from the following truth table, and I'll be discussing the answer for the following question in my next class in the beginning. Till then, take care of yourselves, practice more and more questions, and if you have any questions related to anything that we have discussed so far since the beginning, since part 1, you can discuss in the comment section. You will leave a comment and I'll try my level best to solve your query right there. This was part 2, and we'll meet in part 3 now. Till then, take care of yourselves. Bye.